Okay, today I'm going to go through how to check and hopefully repair one of these Baofeng UV5Rs. These have been very popular with new hams because of their low costs. The unfortunate thing is that the manufacturer is not being very careful when they put them together. And they're quite often putting out spurious output, which is in violation of Part 97 in the United States. So while it's nice to have a low-cost radio, it is the responsibility to check and make sure that they're suitable for operation in the area that you're in. Initially, we got this radio. My son actually wanted to do a review on it because you know they have been so popular. But initially when we got it, it actually performed better than we expected. The operating manual that comes with it, of course, is useless. The person who wrote it didn't really speak English, and it will really give you no idea how to use the radio. We were able to figure out how to operate it from a combination of things on the internet and some experimentation figuring out exactly how the command sequences do work. And it's got a voice synthesizer in it, a few things that are nice like that. So it performed better than we expected initially, but it wasn't very long before issues started coming up. One of which, after a little bit of use, you can see that the cover is not really metal. It's a silvered plastic, and that starts wearing off. Another problem we had with it is that the antenna the connector is spinning on it. So if you cinch the antenna down too tight, then you can't get the antenna off again. But the big deal that came up was spurious output. So I'm going to hook it up on the test equipment here and show you what exactly is meant by that and what it actually costs you in operation. So one of the first things is going to remove the antenna because we're going to need to hook it up to the test equipment here. For the test, I've actually got this set to low power so that it won't overload the equipment and have anything else unusual. So we're actually giving the transmitter its best chance to be clean because we're not driving it up to maximum. Okay, this is a spectrum analyzer. It's used to determine what frequencies are being picked up or put out. Towards the left side of the screen is the lower frequencies, towards the right side of the screen is the higher frequencies. Now, as you can see when transmitter's keyed, you'll see a spike jump up there. This is what you're supposed to see is just a single carrier. This is with a Yaesu VX7R. K16M testing. Okay, so what I'm going to do is I'm going to hook up the probe to the antenna connector here. And this probe is set with a 20 dB attenuator in it so that it doesn't overload the input of the spectrum analyzer. So we hook it up to the antenna here, and you can see I have the ground hooked up there. Now normally I wouldn't do this with the open leads like this because it does accumulate a bit more noise, which you can see on the display there right now. But one of the other quirks about the Baofeng radios is that they come with the reverse gender of the SMA connector. It comes with a male on the radio instead of a female, and I don't happen to have any SMAs appropriate to hook it up the cable direct as I would with my other radio. Now you can see when I transmit here that I've got two spikes on the screen. See, they can pop up when I transmit. Now what you should be seeing there is, like the other radios, there should be one on the screen, but instead we've got another one. K16M testing. Now the problem with that second one out there is that it's about 300 megahertz, which is far outside the ham band. The other thing is that you can see on the screen there is that it's only 3 dB below the main carrier. The main carrier is the one on the left. Okay, now there's more than one headache with this. One thing being at 300 meg, it could be interfering with other people. The other thing is that since it's only 3 dB down, that's about 1.5 watts that's in that spur, which will come out to about 30% of your energy going into the spur instead of into something usable for you. Okay, to disassemble it, we need to remove the battery pack and then start taking some of the screws out here. There's a couple more here and here. Okay, this is what it looks like after the screws are out. And you pull the knob off the top, and you see on the antenna connector and the knob there's a little nut around each that will have to be removed. If you don't have the exact tool to do these, if you just take a screwdriver and kind of work the notch on the nut, carefully so you don't strip the slot, but you can turn it around until it comes off the shaft. Like that. Okay, then you pull the main board of the radio up from the bottom of the case, and you see the knobs will kind of slip down through the holes, and then you can remove it like this. You need to be careful of the speaker wire that you don't break it. The next thing is that there's a series of screws here that need to be removed to get this main board loose. Including the ones on the display. Now some we discovered when we opened it, I don't know if you can see it on camera or not, but this radio has not been opened before, but this screw right here, the top of it, has been stripped out. Somebody at the factory using a screw gun hit it too hard, and it came this way. So we're going to have to deal with that in removing the display. Okay, so my operating theory on this project was to work on these coils here, which appear to me to be a filter arrangement. This is the schematic for the UV5R. And this equates to these coils right here. But unfortunately, in trying to adjust these coils, spread them out, collapse them together, it's having no effect on the spur whatsoever. So these don't seem to be the solution to the problem. One of the things to notice about this board is there are no tuning adjustments on it whatsoever. Most other radios would have variable inductor, variable core inductors or something like that, and this is entirely hardwired. So as of yet, we still don't have an explanation for why some people report these work, but this one definitely does not work. It's got that spur at 300 meg. Okay, where we've gotten to here is that this set of coils here has no effect on the problem, and really looking at them, I think they're more set up for UHF anyhow. They're not really big enough to be for the VHF circuits. Where it looks like the trouble is this chip right here. You can see it right here, which is this chip on the schematic, and I was able to probe it, and I can see the spur coming right out of the synthesizer chip. From what we can tell, it looks like there's more than one manufacturer of these chips, and this one probably has some quality control issues causing it to put out the spur. Considering that this is a surface mount chip on a low quality board, I don't really consider this to be changeable. I suppose if somebody wants to, they could order another chip and try and change that, but it doesn't sound like the most practical idea in the world. Other problems we've seen out of these brand new radios on the vents is they've put out oscillations on the air, high-pitched tones. So they've been an issue in event nets. Hopefully we've been able to show here that it's not a prejudice against Chinese radios that's been the debated topic on these, that there are some real technical issues, and we really would hate to see a new ham end up buying one of these, especially since it turned out to be not repairable at all, but you can see the equipment that was used to test it is generally beyond the scope of what somebody just getting their license would have or know how to use. So with that in mind, it really isn't fair to recommend these radios to anybody starting out because they're not equipped to deal with the technical issues to actually put them into a legal